And I'm going to start sharing. Okay, so Kelsey, did you want to start off with some of those test items?
Sure. So the only ones I had a question.
I got to just make this comment.
Oh.
Okay, the only problem is the order in which the questions come up is completely random.
Ah.
So you can't just tell me a number. You got to tell me something about the question.
I know it was the one where you had to figure out how many numbers were in the set.
Okay.
Let me just find it though.
Well, do you see it there? Is it that one?
I don't think it was that one. Let me just grab it.
This one.
Nope, not that one. Let's see. It was probably the easiest one. I don't know why I got it wrong.
This one.
Oh, so it's the A equals the set into how many subsets does A have?
Oh, subsets.
Yeah.
Okay. That the question?
Yes.
Okay. So how many elements does set A have?
6.
How do you find out the number of total subsets?
Oh, it's the n squared, right?
Well, backwards. It's 2 to the n power.
Ah, that's what it is.
In this case, it's 2 to the 6th power.
Yep. Okay.
And that's 64.
Gotcha. Okay. I think I took the test at like 10 o'clock at night on a Saturday. So I'm like, I don't know which one this is.
Yep.
But okay, now I see. Okay. Yep, I even have it in my notes.
Any others you wanted to look at?
Those were the only ones that I had a question on.
Okay. So I'm guessing that questions tonight are probably all Chapter 3 questions.
Yes.
Okay, so whenever you're ready, go ahead, anybody.
Could we possibly do exercise 3.3, number 5? For some reason, I wasn't understanding the method to get that.
Yeah, okay. So number 5 says, find the truth value of this statement.
Mm-hmm.
If 2 plus 2 equals 4, then
Mm-hmm.
8 equals 5. Okay, now the 2 plus 2 equals 4 is a true statement, correct?
True.
8 equals 5 is obviously false. So,
yes.
So if you look on the screen, you see what that's really telling you is, what do you do with an if-then when you have when the first part is true and the second part is false?
False if the first part is true and the second part is false.
And therefore, this one is false.
False.
False. Okay.
So that's how 5 goes.
Okay. So with 7, I'm going to do that one right
Okay, number 7. Oh, you want to do it?
now.
Let's see. I don't know why my pen is really slow tonight. But so if 2 plus 2 equals 22, well, obviously
False.
that's false. Then, so I draw my if-then symbol. 8 equals 4 plus 4. That's true, right?
Oh, wait.
Correct? 8 equals 4 plus 4 is true, correct?
Wait, just what, 7?
Are we on 7?
Am I looking in the wrong place? Oh, yep, I'm looking in the wrong place. Okay, the second part of number 7 is 4 equals 26. And that used to be false, right?
That's false, yeah.
Okay. So now tell me, if you have an if-then statement that begins with a false and ends with a false, what's the truth value?
It's true because
Yep,
it's false only when it's true and then false, so the opposite would be true.
exactly.
Okay.
So, yep. So it's kind of ironic, but an if-then statement, if the if part is false, it's guaranteed to be true. Right? Because if false, then false, we've already shown that's true. What if it was if false, then true? That's true too, because it's only false in one case. And that's when the first one's true and the second one's false.
Got it.
So it's kind of ironic, but when an if-then statement begins with a false, it's guaranteed to be true.
Okay.
I know it's probably the first time you've heard that, and it sounds kind of strange, but yeah, that's how it turns out.
Could we do 13 in that same exercise?
Yes. Okay, so number 13.
I did the work and then I had the two conclusions and the two conclusions didn't match. So I'm thinking maybe I needed to do one more conclusion or maybe I circled the wrong direction. I'm not sure.
So really, this is the same issue we were talking about on number 5 and number 7, because they're asking you, when is this if-then statement false? By the way, do you see that this is an if-then statement? I know there's no then there, but isn't it implied?
Yeah.
If you've got the time, then we've got the beer. Okay. So what, under what conditions is an if-then statement like that false? When is, in other words, I'm asking you to repeat, when is the only time an if-then statement is false?
If the beginning is, if the if is true and the then is false.
That is correct.
Okay.
So now make the if part of this statement true and the then part of it false, and you've got your answer. So when will this statement be false? When you've got the time and when we don't have the beer.
Okay.
Because then the first part would be true and the second part would be false.
Got it.
So 13 was again hammering on that same if-then principle. So the answer is, you've got the time, we don't have the beer. That would be the condition.
Got it.
I forgot to warn all of you. You probably noticed this if you're watching the videos, that there's a lot of beer in this chapter.
Yes.
Yeah.
That's funny.
It is kind of funny. Yeah. Guy's got a strange sense of humor.
Yeah.
Yeah. And it's almost like he knows about Milwaukee.
Right.
because I don't know if you know this, but you probably don't. You guys are too young to know this. But if
That's
you,
a High Life, right?
what's that?
It's High Life, right?
Yeah, that's their commercial.
Yep.
It just came back again. If you've got the time, we've got the beer.
Yep.
It's actually
Nice.
the Miller campaign. Yeah.
Yeah, we my dad had this old beer sign and it said that. So
Yeah.
I for a long time.
Yeah, and I think that was their what, their advertising scheme back about, I don't know, 10, 15 years.
Wow.
Yeah.
And then they just brought it back again, I think like last year I heard it. Yeah. Kind of weird.
Do you think that we could go back to lesson 3.1 and look at number 13?
Certainly. Okay, I'm going to make some space here. Okay, 3.1, number 13. Well, I don't know why pen is like it's numb. Okay, 3.1, number 13.
So for whenever it has a but,
Yes,
so that would be like an and.
that is correct.
Okay.
So then all you really need to do with 13 is violets are blue and
Right.
what's the second part? Roses are pink.
Yep. Okay. I was just confused as to like why but was in there too.
Thank you for getting that. Yes, but I know but has a different meaning in English, but in logic, but might as well just be an and.
Okay.
Yep.
Can we look at 3.317, the biconditional?
Yes.
Okay.
3.3, number 17.
17.
Yeah. You'll have to forgive me. It looks like a kindergartner is writing today. I don't know. This pen is really weird. Okay, but anyway.
It's okay.
3.3, 17. Okay. So construct a truth table for if P, then Q and R. Okay. So we need to, let's see, let's just write it down. P, then Q and R. Okay, so for a truth table, we have two statements, P and Q. So we're going to set up just P and Q, and then you do your standard truth table, which is what? True.
True, 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 and then 4 falses. Oh. Should I wait on that since the R is later?
Oh, we got R too. Thank you.
Okay.
Okay, thank you.
Yeah.
I'm a little bit numb here tonight.
That's okay.
So we need to make room. Not that those are wrong, but we need to make room for an R. And with 3 variables, we got to go, what, 8 down.
Mhm.
And the first thing we're going to do is we're going to go what?
4 truths, 4
Half.
falses.
So then instead of going by 4, we're going to go by 2s.
True, true, false.
It's going to be painful. This thing is so slow.
Sorry.
No, I mean painful to wait. And then the last one is by 1s. Okay, so the first thing we got to do because of the parentheses is we have to do the Q and R. So now you got to think of the rule for and. And the rule for and is what? Only true when they're both true?
Mm-hmm.
So true, true, that's true. True, false, they're not true. False, true, they're not both true. False, false, they're not both true. True, true, they are both true. True, false, they're not. They're not, and they're not.
Mm-hmm.
Okay, now P, I'm going to just copy what we got here under P. Same thing we got on the first column here.
Mm-hmm.
So now we got to follow the if-then rule. Only false when the first is true and the second is false. True, true. True. True, false. That's the bad boy, right? Right? When the first is true and the conclusion is false.
Yep.
Mm-hmm.
True, false. We got another bad boy. And another. And the rest are all true because the if part is false. So in a truth table, the way I signify this is I just put an arrow. Yeah, this is kind of your final answer column here. So what this is saying is, well, this statement's true when all 3 are true. Second one, the statement is false when R is false and the rest are true. And so, you know, and all the conditions are there. That would be the answer to number 17. Now, how the table is designed, it doesn't matter if your columns are slightly arranged in a different way, but let's see, how can I put this? So the design of the table is not important. The answer will always be the one that's above the arrow here. You're silent. Does that mean you're stumped or you're just writing stuff down?
No, that makes sense. Do you ever have 2 columns that are the answer, or is it always just going to be 1 column?
It's what's the final logic thing that's done? Because
Okay.
of the parentheses, this thing right here is the final thing being done. And so the answer is, it's always going to be 1 answer, and it should be below that last operation.
Okay.
So no, you won't have I mean, when I grade your work, except you're going to be doing multiple choice, but I mean, in your notes, I want to look at this whole table.
Right.
But the answer is technically just the 1 column here above the arrow.
Okay.
Mm-hmm. So there's not like a way to check it with the other columns. It's just that is the answer.
Yeah, there's really no way to check this. Well, I mean, except you could go back and do it again real carefully, but I mean, there's no like reverse process or anything you could check it with.
Okay, that's what I think I was looking for and didn't find. Okay.
So now if you look in the back of the book,
Mm-hmm.
I don't remember what this looks like, but they may not have the same looking table, but this answer should be identical.
Yes.
Yeah.
Okay. Oh, that answers my other question then. Good, I'm glad. Because number 19 it says are the statements in problem 17 and 18 equivalent. And I had done that and they hadn't matched up, but now that we did that, it matches up. So
It does?
it does, yeah.
Oh, you weren't looking at the so-called answer on one of them, I take it.
No, I did 18 earlier and I had gotten true, false, 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 true, 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 true. And I think that matches up with the one we just did right now.
Oh, that is the same. This one is the same. Oh yeah, this is the first part. Okay.
Mm-hmm.
Got it. Yep.
Awesome.
Yeah, and what is it? How do you show that two statements are equivalent? You show that their truth tables have the same final answer. So yes.
Got it. Perfect. Okay. Thank you.
I have a question on 3.2, number 31.
All right. So this is not the right one, but it was close. Okay, number 31.
Yep.
We'll do that below here.
So basically my biggest question on this one is when you have to find the, what is that called? The negation for the final column, right?
If you, yeah, I got to find that problem. Hang on. 33.1. So that last negation sign on the outside,
Yep.
that's where your final answer would occur because that's the last operation that would be done.
Okay. And my question really was just like which column to the left are you taking that from?
Why don't I just do, let's just do it.
That works.
Okay, so we're supposed to do, make sure I get the right one here, not P or not Q.
Yep.
Okay, so the truth table, let's see, I'm going to move the 31. Hang on. So the truth table, we need a P and a Q. That's pretty standard setup. We only have two statements, so TT, FF, TF, TF. Okay. I suppose we could throw in a not Q here too. Sometimes I will do this when I'm doing a table. Not, it just makes it a little bit easier. False, true, false, true. Okay, so the first thing we got to do is the parentheses. P or not Q. Now, or is what?
False, only if both are false.
Yep.
So here we have true or false. One is true, the other one's false. And as you well know, that's a true. Right?
Yes.
And then P or not Q, true or true. Well, they're both true. We're good. Here we have false or false. That's a false. And then here we have false or true. That's a true. And now here's the last statement. So that's the last thing we have to do. And so that's going to be our answer. Okay, so what's the negation of true? False. Negation of true. False. Negation of false. True.
Oh. Okay.
So there's your answer column.
Okay. I don't know what I was thinking, but yeah, you just take the opposite of the other column.
Yep. And now we could, I don't know how advanced I should get here, but you could use De Morgan's law to do this. Do you remember how De Morgan works?
Yeah-ish.
So what you have to do if you're taking negation of a set of parentheses is that's equivalent to, I mean, this is you don't have to do this to do the problem. We've already done it. But you negate the first. You negate the second. What happens when you negate a negation? It becomes regular. And then you have to inverse. You have to flip that thing over.
Yep.
So if we did this, we'd get the same answer. You know?
Yeah.
you would get, I'm not going to do it, but you would get false, false, true, false. Anyway, De Morgan's law is going to come up. And so I didn't need to show that to you, but there's a little more depth. That would have been another way to do the problem. I wouldn't expect anybody to do it, but yeah, I don't get very many chances to do some live teaching, so I thought I'd throw that in there.
Okay, and then do you think we could do number 25 for 3.2?
Yep, 3.2, number 25. Yep, we'll do it off to the right here.
Okay.
3.2. Number 25. Okay, 25. Suppose that G is false and J is true. Okay, G is I go to college. J, I join the Army. So write the statement. So first of all, number 25, I go to college. Or I join the Army, but not both.
So I know that but is now an and, but I'm not sure how to do like.
Okay, yeah. So did you? This is the one thing that the book is a little bit off with. Did you view the video on this lesson?
Yeah. Yep.
Okay. So the book didn't show you this symbol, I guess. That circle with a cross in it. That's called the exclusive or. That means one or the other, but not both.
Okay.
And that's the perfect thing for this statement. I go to college or I join the Army, but not both. So here, I mean, there's the statement. Okay. Now, do you remember the rule for that?
It is true only when the statements are different.
That's correct.
Okay.
Now we got to fill in. So G is false and J is true. And because the two statements are different, it's true.
Yes. Yep.
So like you said, true only when they're different. They're different. So first, the first part of that is writing the logical statement. And I'm guessing that obviously was a little bit hard. Okay, we got that.
Mm-hmm.
And go back to the crazy directions and say, all right, G is false and J is true. Now, what happens when you do an exclusive OR on false true? And that's true.
You do that for all the ORs or in the word sentences or not necessarily?
What?
So like if I had a different word problem that used the word or, like say for instance 25 following, would that be the same type of deal or not really?
When you see or, you can assume it's this one. That's called the inclusive OR.
Okay.
The only reason I use this one in this case is because of those words, but not both. Because what it's saying is you can have one, you can have the other, but you can't have both. It's kind of like you win, let's say, a lottery, and they say to you, hey, you have a choice. You can either take these 2 tickets or you can take the prize, but you can't take both. And so anyway, yeah.
Makes sense.
So I wish the book would have shown you that, but they didn't. The book never touched the exclusive OR. By the way, there is a way to do this problem without that, but it's much complicated. You got to break it into 2 more steps. By the way, I don't know if you looked ahead on the schedule, but I just wanted to talk briefly. Okay, here's the schedule for the week we're in right now, week 5. You're supposed to be done with 3-6. And then next week, there's really just 3-7 and a presentation by me, closing out with notebook and test. Now, it could be that there's there's an awful lot jammed into this one tonight. And just so you know, I'm kind of reserving as an option. I might just change the schedule a little bit if that seems too rushed. You're probably feeling a little bit overwhelmed with all the logic. And that's not all. Last time, because we spent most of our time on the test, we didn't go through 3-1 or 3-2 either, did we?
No.
And so actually you've got 6 lessons, and I don't know if you'll have enough time to ask about all 6 tonight. But anyway, let's just decision on that. So actually, that's what you guys have been asking about tonight. You've been asking about last week's stuff, 3-1 and 3-2. Yeah, that makes sense.
Yeah, I'm kind of a little bit behind this week. I'm just doing. I'm in the middle of 3-3 now.
Yeah, so you've got a ways to go.
Yeah.
Yeah, I think I'm probably gonna. I'll change the schedule a little bit.
Okay.
But I don't know if I'm going to rewrite the web page, but I'm thinking this test, which is scheduled for next week, might get moved back a week.
Okay.
So we'll still focus on this week and next week being done with the chapter, but then we'll have a week to
Mhm.
check in and do more questions, and then we'll have the notebook and test be in week 7.
Okay.
Okay.
So I should have realized, yeah, tonight you guys all have been asking questions on 3.1 and 3.2, which is fine. That's good. So, Kelsey, did you have any 3.3 questions?
No, not yet.
Okay.
Could we do E53?
Which one?
Exercise 3.353.
Okay. 3.3, number 53.
Mm-hmm.
Okay. So 53, a mother promises her child, if you eat the spinach and the liver, then you may go out to play. So do you see how I labeled eat the spinach S, and I
Mm-hmm.
labeled eat the liver L, and you can go out and play I labeled as P.
Yes.
So do you see how I labeled the statement? If you eat your spinach and your liver, then you can go out and play. If
Mm-hmm.
SL, and that's really gotta be in parentheses, then P. Okay. So now what's the rest of this? The child eats only the spinach. I don't know why I wrote that the way I did. So here, let me put it down here. Spinach and liver, then you can go out and play. Okay, and now below that, what did the book tell us? The child eats only the spinach. So in other words, this part is true, but she didn't eat her liver, right?
Mm-hmm.
So that's false. And what's true and false?
False.
So that's the if part. And so the question is, the mom let the kid go out and play. What do you think? Did she lie? She didn't, because if the first part is false, the statement's going to be true. Remember that? And an if then. The first part's false, then false or true. Hey, if an if then starts with a false, it's true. So mom did not lie. Does that make any sense?
I got lost towards the last sentence.
Okay.
Yeah.
So here, I guess I do have it up on top. Here, let's look up on the top.
Okay.
Eat your spinach and your liver, then you can go out and play. All right.
Mm-hmm.
The kid ate the spinach. So that's true. The kid did not eat the liver. So that's a false. And what's T and F?
False.
False. So now we've got false. Mom let her go out and play, so that's true. Now, in logic, what's the truth value of if false, then true?
If false, then true.
Yeah, look in your if then table.
Okay. Um,
If false, then true should be true. Right? Because the only time the if-then statement is false is when the first is true and the second is false.
Right.
mhm.
So because that whole thing is true, that tells me mom did not lie.
Okay.
She told it. So she was not going back on her word. You know, she really did keep, you know, she followed.
That's probably where I went wrong, was like not memorizing the part that says if you have a false statement in the first if clause and the second part is true, then it's true.
Yeah, that's not very natural, is it?
No.
No.
That's the hard one to remember.
Yeah.
So when and if then begins with, it's like saying, if monkeys fly, then I will give you $1 million on the last day of class. Okay, so am I safe? By the way, I don't have $1 million. But am I safe? I am.
Yeah.
Last I checked, monkeys can't fly. So that first statement, if monkeys fly, that baby is false. And so I don't have to worry about it. You know, I don't have to worry about it coming out. So, yeah. So I did not lie if I don't give you the $1 million. You know, that's like somebody says, hey, are you going to vote for this particular candidate? And the guy says, yeah, when hell freezes over.
Right.
What's he saying? If hell freezes over, I'll vote for him. I think he's pretty safe. Hell's not going to freeze over. So the first part, if hell freezes over, that's false. And you know, yeah, okay.
Can we do 3.415?
Yes.
Okay.
Okay, let's do it over here. So 3.4, yeah, now this is Euler diagrams. Okay. Number 15 on 3.4. Let me get there. Okay. Oh no, this one says use a truth table, doesn't it?
Mm-hmm.
Okay. Use a truth table to show that in general, the converse and the inverse are equivalent. Okay. So, if P then Q, well, I guess I don't need, hang on, let me save space here. Let's get rid of that. So, who can tell me the
It's Q then P, or no?
That's correct.
Okay.
So there's the converse. That's the converse. All right. What is the inverse? What's the inverse of if P then Q? That's where you leave them both in the same order, but you negate them both. So if P then Q, the inverse is if not P.
P then not Q.
Correct. So now you're supposed to, those two are equivalent. So basically, we just got to hammer out a truth table now. Now, I'm going to move this 15 over again. I don't know why I can't plan ahead. Okay, 15. So we need to do a, got one of those stray. There we go. So we need to do a P and a Q, and that's probably going to be enough. True, true, false, false. True, false. Is that big enough for you guys?
Yep.
True, false, true, false. Okay, let's do if Q then P. All right, if true then true. The only time an if then statement is false is when the first part's true and the second part's false. So that's true. Okay. If false then true.
True.
If true then false.
False.
Yeah, that's the bad one. If false then false.
True.
Okay, now let's come over here. We better throw in a not P and a not Q. Yeah, I wish I had room here. Let me get rid of that 15 completely. Okay, not P is of course the opposite of P. False, false. True, true. Not Q is the opposite of the Q column. False, true, false, true. Okay, so now taking a look at these two columns, we can answer this one over here. If not P, then not Q. If true, then true. That's true, right? If, why did I do that on the bottom? Why did I go upside down? Hang on. Let's do it on the top. Okay. So, if false, then if false, then if false, then false is true, right? If false, then true.
True.
If true, then false.
False.
If true, then true.
True.
Now, are those two columns equivalent?
Yes.
We've done it by truth table. So when you want to show that two things are equivalent, you really got to kind of hammer out the truth table for each one and show that the truth tables come out exactly the same.
Thank you. Wow.
You're welcome. That's, now I can stick in the number 15. So, Leah,
Yes.
you don't have to answer if you don't want to.
Mm-hmm.
How far did you get on your assignment work thus far?
Well, I had off today and I worked all day on it. So I just went to I didn't even start on 3.6 yet. I've been doing all day. So
yeah, well, so,
yeah.
Okay, and you don't have to be done by today. I was just curious
Okay.
how it was coming, and Okay.
It's coming slowly but surely.
Yeah, and this chapter, it takes time. That's the one
It
thing.
does.
One thing, I'll be honest with you. The only thing I don't like about the adult classes is they're too crammed together.
Mm-hmm.
Mm-hmm.
And this would not be. I mean, when I teach this this takes a whole half a year for me to teach. And of course, we teach it on Monday, Wednesday, Friday. So you've got 2 days for each lesson. And you guys just don't have that luxury.
No.
Yeah.
Right.
So I feel a little bit for you. I get it. Again, and that adds to the idea that I think what I'm going to wind up doing is that the tests listed for week for week 6, I think are going to be week 7,
Okay.
like we said already.
Yep. Could we look at 45 in that same lesson? I started getting into tautologies and contradictions, but that's where I was like, wait, what?
Okay, I'm only getting about some of your audio, so it's like real spotty. Could you just try that a question again, please?
Sure. 3.4 and then 45.
45?
Mm-hmm.
I got to find the spot here.
Okay.
Here we go. 3.4, number 45. Okay. Show by means of a truth table that the statement. Okay. So do you know what a tautology is?
It's a truth table, a type of statement where I can't explain it real well, but like a table that has truth statements that are all valid.
Yeah, the whole truth table comes out to true, 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 all the way down.
Okay.
Let's see what we have here. P and Q. So that should be the statement, right?
Mm-hmm.
So we have 2 statements, P, Q. So pretty standard, true, true, false, false, true, false, true, false. Okay, parentheses first, P and Q. Only true and both are true.
True, I think, for the first one.
Yep. Does that column look correct that I just wrote?
Yes.
Okay.
Oh, wait. You mean the middle column or the Q column?
The P and Q column.
Oh.
Oh. Are you not? Okay.
Yeah, I didn't finish that column yet. Sorry.
Oh, okay. Yeah, I maybe went too quick on setting it up.
For the middle column, I got true, true, false, and false.
No, that's okay. So this one right here,
Yep.
It can't be because remember, it's only true and both are true.
Oh, I was going by the other rule. Okay.
Well, yeah, you gotta.
False.
Yeah, you gotta really nail rules. Yep. Okay, then for P, I'm just going to copy what I've got over on the left. true, true, false, false. Okay, so now all we got to do is if this column, if this column, then this column. Okay, so let me do that in red. So if true, then true. So now we got to use the if then rule. If true, then true is true, right?
Yep.
If false, then true.
True.
If false, then false.
True.
If false, then false.
True.
So look at the answer column. It's all true. That's called a tautology.
Yes. Okay.
Okay, I followed you until the true and the true is a true on the first column. What was the formula for that again?
Where I'm not sure. What do you mean by the first column? You mean the P and Q?
Yeah, the P and Q. You have true in black and then true in red and then true in black on that. So why is the true and true? Why is that true again?
It's the if then rule.
Mm-hmm.
If true, then true is always true. Remember, if then, what's the rule? Only false when the first is true and the second is false.
Ah, I see. Yep.
So therefore, if true, then true would be true.
Got it. I was looking at a different rule.
Yep. Yeah, you just nailed one of the big problems. You really have to memorize those rules.
Mm-hmm.
You know automatically. Oh, yep, I got to use the and rule. And the and rule is only true when they're both true. The if then rule is only false when the first is true and the second is false. The exclusive or rule is, only true and different, etc. You got to be able to reel them off quickly like that. So by the time we get to the end of the chapter, I'll need you to be pretty good at that.
Okay.
I appreciate, you guys have to be prepared in order to ask these questions that you're asking. So I appreciate your questions. I can tell you dug in and you need to ask about something. That's excellent.
Oh,
Thanks.
I appreciate your help.
Well, I'm glad to give it. Did you guys? Oh, did either of you get extra credit on your notebooks?
Yes.
Did you notice on your grades that the test score reflected that?
Let me just double check it.
Well, anyway, maybe you don't check it right now, but check. This is your home. Just check that when we're done.
Okay.
I'll send you that email.
If you plus 5, that 5 got added on to your test percentage score.
Okay.
So
yeah, I think it did.
You should see that was added on there.
Yep.
Thank you so much for your help. It's encouragement. So
You are welcome. Thanks for the good questions. Appreciate all the
yeah.
hard. Did you want to hang it up, or I don't care if it's 8 o'clock. If you want to ask some more questions, we could still do that. Or have you had enough? You got to maybe go take some Advil now.
Yeah, this stuff is not easy. These ones make you think.
I wouldn't mind doing one more.
All right, let's do that.
Okay. Could we do 49, 3.4,
Yeah.
49? Okay.
Okay. I am going to see. Hang on a minute. 3.4 for 49. Okay. It's going to take me a few minutes to get that up.
Mm-hmm.
Okay, here's number 49. Now, first of all, this has got some rather complicated directions. So let me talk about the directions. The directions say, all right, we're going to give you two statements. You're supposed to determine whether the two statements are equivalent. That would mean that their truth tables come out to be the same. Or the first one implies the second, or the second one implies the first. Now, we haven't talked about an implication yet tonight. Do you know what an implication is? An implication is when one statement is the if and the other statement is the then, and it turns out to be a tautology, then that's an implication. Okay, so anyway, here's number 49. The two statements are not P and Q, and the other one is if P, then Q. So you see them up there on the top?
Mm-hmm.
All right. So technically, this middle column would not be there yet. Hang on. I'm just going to. Wow, this thing is slow tonight. Okay, there. It's very crude, but I blocked it out. So I've got not P and Q, and if P, then Q. So first of all, I have to figure out the truth table for each of those two statements. I'm not going to go through that right now, but for not P and Q, I got false, false, true, false.
Mm-hmm.
For if P, then Q, I got true, false, true, true.
Mm-hmm.
So are they equivalent?
No.
That's correct. So that's out. So now the question is, does one imply the other? So what I did, get rid of that red box, is I said, well, to find out if they imply one, I could try ifing this one. You know, if the one to then the other. All right, and then figure out the truth table. If false, then true, true. If false, then false, true. If true, then true, true. If false, then true, true. So the if then is a tautology. Well, that tells me the first one implies the second, and we use this special symbol. It's like an equal sign with an arrow on the right. that means not P and Q implies if P then Q. And that's really special when that happens. That's why I put 2 exclamation points. It's like, bring out the trumpets. We have an implication. Anyway, that's kind of you're probably wondering, why am I shouting in logic there? But that's what was going on. Now, if that one, let's say that didn't turn out to be a tautology, then we would have had to turn this arrow the other way. And if P then Q, then with that, and see if that turns out to be a tautology. So this could get 49. You really have 3 things for each problem to check out.
Okay.
Those are actually pretty long problems.
Got it. I'll zero in on those for tomorrow.
Okay. Let's see, 49, 51, 53. Another one of those implications. 51. Another one of those implications. I guess all the odds turned out to be implications, but the evens, that's the trouble when I only have you do odds. You sometimes don't see every kind of problem, but go back to 49. Any others you want to ask about tonight?
I think I'm good for tonight.
Okay,
Same here.
sounds good. Have a good evening, what's left of it, ladies.
Thank you so much.
Good night.
Yep, bye.
Bye.